All right, today we're going to be looking at Chapter 11, Systems of the Linear Equations, Solving by Graphing. Have three objectives. We're going to determine whether an ordered pair is a solution to a specified system, determine whether a given system is consistent or inconsistent, and whether the graphs are dependent or independent, and then we're going to just solve them by graphing. Okay, so when you hear that word system, and we'll be doing a lot of systems, it'll pop up again later in the semester. System just means more than one. Okay, so generally we're dealing with two. So here, this curly bracket, we have two equations. And then on the right side, we have solved those two equations to put them in slope-intercept form. And then what we're going to do is graph those two equations. And then once we graph, either the lines will cross and we will get a solution. They may be parallel, or they may be the exact same equation. Okay, so the solution is an ordered pair, so an x value and a y value that satisfies both equations at the same time. So if I put x and y in here and that same x and y in the second equation, both equations will come out true. Okay. So here's some examples. They give you a couple equations. They give you this ordered pair 2, 1. X is 2, y is 1. So they plug it into the first equation and they get 0 equals 0, that's true. And then they plug 2, 1 into the second equation and they get 7 equals 7, which is true. So both of those equations will be true by plugging in the ordered pair 2, 1. So I got a few more examples. Okay, this terminology is going to be very important. So here's how you get one of those second objectives, second and third objective actually. We're going to graph both equations. We're going to look and see, do they intersect? Okay, so you have three scenarios. If the slopes are different, okay, the lines will intersect at one point and they will have a single solution. Down here at the bottom it says a system is consistent if it has one or more solutions. So different slopes means consistent. They're going to have one solution. So one solution, or if it does have a solution, that means consistent. If the lines have the same slope, they are parallel, they will not cross, they have no solution. So go back down here, a system is inconsistent if it has no solution. So the case where you have parallel lines, those will be inconsistent. And then you have a third scenario if the lines are the same. So if they're the same line, when you solve them, you get the same equation. It says there are an infinite number of solutions because those two lines touch at every point. So that would also be consistent. That's one or more. So you have some visuals of two lines intersecting, and you can see the ordered pair, 1 in the x direction, 3 in the y, where they cross. You're given the solution, the example where there's no solution. These are parallel lines. And then we see the last two terms, dependent and independent. Dependent means they're the same line, and then independent means they're different lines. So that's the basic difference there. So if you have these two equations right here, when they solve them for y and graph it, it's the exact same line. So we would call this dependent, okay, because they're the same line. And then if they were different lines, we would call it independent. Okay, so here's probably one of the most important visuals that you'll have in this section. You have two lines, one solution. That's called consistent, independent. Independent means different lines. Consistent means we get a solution. Parallel lines. Inconsistent, meaning there's no solution. These two lines will never cross. Independent, meaning there are two different lines that you can see. And then the last one, we just have one equation or one line graph, but you see two different equations. And we get inconsistent and dependent. Then you have a few more examples of showing solutions and graphing these equations. And we can also graph with the calculator, but I think for the most part, the computer will graph it. I will try to show you maybe once or twice how to graph these and get the intersection in the calculator.